into that. But basically flammable, it's a compressed gas, it's acutely toxic. The warning usually has something to do with the respiratory. It's an irritant, skin or eye irritant, respiratory irritant. The last one is, yes, it's a health hazard, but you know, that's not really, if it's toxic, it's also a health hazard, right? So it's more than that. It has some carcinogenic or mutagenic properties. That's what that one means. It lists a whole, right, if you look at the symbols and the description, it lists a whole different thing, so not all applies for everything, so some of them are specific. But I was looking for at least one word from the definition for each one of those. I think this is probably the most difficult one, right, in all of it. We have a storage tank. So long problem statement. It says cyclohexane, not ethylene oxide like this one here, right? Cyclohexane, and you basically you have to look at this one, right? So we have a storage tank. This tank is actually used to feed. There's no pump, right? So we're gravity feeding or pressurizing. This is pressurized to gauge pressure, and you're feeding it. You're asked for the maximum flow through the valve here into tank B. Okay, so the reason I put from the valve into tank B is so that you don't add the 5 meters of the tank height, right? I'm just asking for the velocity into here. It obviously accelerates down to here, but I'm asking for the velocity here. What you have to do, which is I think what the majority of students actually fail to do, your mass and energy balance has to be across these two systems, okay? And maybe not including tank A, right? But so you want to take, your first point should be up here, because the maximum velocity into tank B is when this is full. Okay, if you have no liquid in this tank, you're not going to have any flow into B.
Damn, I should have just said that.
Right? Which is what, that wasn't supposed to be a complexity. I thought that was sort of a given in the problem
I almost fucked
by
that
the
up.
problem statement, right? It wasn't
Fixed it the
meant
last
to be
2
a,
minutes.
it wasn't meant to be a trick question. Okay, but the maximum would be when this tank is full, when the pipe is new, and of course when there's no flow into tank A. But I had, the wording was such, actually it was a figure caption that said, this is the design to fill tank A and B, although not at the same time, right? So maximum flow, of course, would be into tank B would be when there's no flow into tank A, right? Yes?
I know it's the next problem, but is A and B outside of the dike, like above the dike? I guess that you could have.
I was trying to draw it so that without taking up too much space, so that they're not, it's supposed to be right under tank A and B.
Okay.
Rectangular space right under. And I was trying to draw it so that, if you calculated, which you really didn't need to, if you assumed a constant flow, the dike would be about 1/3 full. It doesn't really matter how full it is, because the area is what's important. But I was trying to draw it so that the reactors themselves wouldn't reduce the area of the pool.
Oh, I see what you're
Right.
saying.
So, and the other thing that I had pointed out, to try to make it easier, this is not the whole problem. No, that was the other one. Oh, that's the next one. Okay, so I think that the main problems I saw was actually with the mass and energy balance across this problem, right? Because the problem with putting it over just this section, right, just the pipe section, I think that was the majority of what students did, is that you don't know the pressure at this point. The pressure here at the inlet to that is not equal to PG. because you have the hydraulic pressure of the liquid above it,
Oh shit.
right? That's what's forcing the liquid out of here, okay? So, right, that wasn't meant to be a trick question, okay? My intent was that was pretty straightforward, right? So I thought I looked at what the average was on this one.
If you-
But there was, I think there was one student who got a 55 on this problem, just to put it in perspective.
Damn.
Yes.
If you made
I
your
know.
system at the entrance of a pipe,
Out of 55.
wouldn't your
Only 1%
speeds
got
cancel out and you couldn't like really
Yes.
solve for it?
Yeah, well, you can still, because you have a sum KF times U. So you can still solve for U,
Mm.
and it's a lot
Oh.
easier in that sense. You have an equation that's a little bit easier. But, I would say that was the most, where most of the points were, the mass and energy balance over across the system. And then in the third one, same thing, right? So here is what they disconnect this to repair it, and then the operators go to fill this one, but open the valve to B, which means it all flows out. So how did I word it? They discovered this 30 minutes later, but the secondary containment, the square dike, caught all of the liquid. So that's really all that you need to know, and that it was completely covered, right? I didn't say that. That's what I put 30 minutes to really, right, show that this would be enough to cover it. And you're asked if the workers are overexposed if they work a 10-hour shift near the tank.
So you never used the 30 minutes?
Yeah, something big.
Minus the 30 minutes they were in the control room during the fill. Why did I put that there? To show that it's not a filling operation. You can ignore the filling term.
Damn it.
Because they're in the operating room during that time. Okay? If you have, and then I really want you to look at what is the exposure, right? Your final concentration is obviously a lot higher than the time-weighted average, but I wanted you to show me that you know how to calculate the exposure as well, right? Which is, if you had done the exposure times 10 over 8, forgotten about the 30 minutes, I didn't take any points off of that, I don't think. I can't remember. I think most students actually got the 9.5, the 10 minus the half hour, so.
Nope, not me.
I think that was, in terms of the tricks, there wasn't supposed to be any tricks. It was supposed to be straightforward. But it's, at the same time, it's hard to word something so that it's completely non-ambiguous. So, I got the exam.